Good morning, students. Welcome back to the session. Today, in this video, we'll discuss about plane mirror, types of reflection, and the last one is verification of laws of reflection. Okay, let's start with the plane mirrors. See, we have mirrors and the glass plates, but by using the glass plate, we did not get the image, but by using the mirrors we can get an image. By using the glass plate, why we can't get an image? Because that object acts as a transparent object, or depends on the design, sometimes it acts as a translucent object. But coming to the mirror, this is made up of glass plate, and it has the two surfaces. Glass plate has two surfaces, front and back. So any one side of the surface, mostly any one side of the surface is made by depositing a layer of metals of either silver or aluminum as a layer on the surface with these metals. After that layers are covered by paint. Then that surface acts as a reflecting surface. Due to this reason, we get image by using the mirrors. Okay. And for the reflectors, we are using the metals silver and aluminum. See, silver is costly, so nowadays they are using the aluminum. Silver and aluminum both are the best reflectors of light. See here, this is the view of plane mirror. If you see the plane mirror, you can get the front view, you can get the image. But in the ray diagrams, other side it is coated or it covered with the cardboard or something. But in ray diagrams, how to represent a plane mirror? For that, you draw a horizontal line, and which surface is coated is that you have to represent with these lines, dotted lines. Then this surface acts as a reflecting surface, and the other side, the incident rays falls on the mirror. The incident rays falls on the mirror. So like this we have to represent. This is an 1 mark question. Draw the diagram of how you will represent a plane mirror. Draw the diagram. Means just either horizontal line or vertical line. Which surface is acting as a reflecting surface? You can represent like this, or otherwise like this also you can represent. So if you represent these dotted lines, so before opposite of this, on this the incident rays will fall and the reflection takes place. If you take here, the incident rays will fall on this mirror. So this is about the plane mirrors. Okay. We get image by using the mirrors, but why you can't get image by using a paper or book or wood or any other objects? Actually, if you take the mirrors, the surface of the mirror is very smooth, and it is polished surface. Due to that, reflection takes place properly. The reflection takes place properly. But if you take a book or something, they are also smooth, they are also having the smooth surface, but when compared to the mirror, that the surface is not that much smooth or polished surface. Due to that, some of the rays may enter through that book or page. It does not completely reflect the light. It does not completely reflect the light, either book or whatever may be. Due to this, by the book or by any other object, we can't get image. Suppose if you stand in front of your wall, why you can't get image on the wall? Because the wall is not a smooth surface, it has a rough surface. So on the rough surface, reflection does not take properly. Due to this reason, we can't get image on the wall. But if you take on the mirror, it is very smooth and polished surface. So reflection takes place properly. So there are two types of reflection. How many types? There are two types of reflection. Reflection are of two types. The first one is regular reflection and the second one is irregular reflection. So regular reflection means suppose a beam of light rays falls on a smooth surface. Here for the regular reflection the surface should be smooth. Suppose if you take this is a smooth surface and if a beam of light rays falls on this surface, then immediately from this surface a parallel beam of reflection takes place like this. So here the beam of rays are parallel and after the reflection the reflected rays are also parallel, and due to this reason you can get a image, and here the regular reflection takes place. And out of these parallel rays, few of the rays are reaching to your eye, and due to this reason you can get the image. Coming to the irregular reflection, why we can't get image on the book or otherwise on a wall? Because here the surface is not smooth, maybe some irregularities are there. So here on this rough surfaces, if a beam of light rays falls, then reflection does not take place properly. Reflection does not take place properly. Due to this, these reflected rays will not reach to our eye properly. So that's why we can't get image. Now, the third one is lab activity. So, we discussed in the previous video about the laws of reflection. How many laws are there? 2. Angle of incident is equals to the angle of reflection, and incident ray, reflected ray, normal, all these three lie on the same plane at the same point, touch at the same point. So that we have to prove by an activity. So for lab activity, what is the aim of lab activity? Verification of laws of reflection. What are the materials required for the laws of reflection? We required mirror strip, drawing board, white paper, pens, clamp, scale and pencil. So these are the materials required to prove this laws of reflection. Now, procedure part. How to do this activity? First, you take a table. On this table, you take a drawing board. Okay, you take a drawing board. On that, you fix a white paper by using the drawing pins. You fix a white paper by using the pins, drawing pins. Why we have to fix this paper? Because while drawing that lines or to get the image, the paper should not be disturbed, move. So that's why we have to fix the pins, 4 corners. So this is one of the precaution. And next, okay, after arranging this, take a scale and draw a line. You have to draw a line. So after drawing this line, immediately you have to draw a normal. How to draw a normal? You take the protractor and place it on this line and find out the 90 degrees up and down. With the same point. At what point you chooses? At the same point, up and down, you find out the 90 degrees and you draw a normal. Then draw a line. Draw a line. So I will rub all these. Then only I will show you that white paper drawing. So this is the white paper. And fix the 4 pins, 4 corners, and take a scale and draw a line and mark at one point at the middle of that line and draw a perpendicular or normal either by using the protractor. This is the protractor. So 90. And with the same point you place this protractor and draw and find out 90 degrees. Then take the scale and draw the normal. Draw the normal and you can extend this line. Now, again you have to take this protractor. And this acts as a normal. And this horizontal line acts as a, we have to imagine that it is a plane mirror. So plane mirror means definitely we have to represent the reflecting surface of that one. So this is the reflecting surface and this is the front view. So in this front view, suppose a ray of light incident on this mirror at an angle of 30 or 40 or whatever may be. So for that roughly we'll draw one ray which is incident on this mirror. So again you take the protractor and place it on the normal, and from the normal you have to measure. Suppose initially if you take 30 degrees, you take that mark that 30 degrees, and by using this you draw a line. Okay, then here you will get an angle. This angle is formed in between the normal and this is the incident ray. So this angle we have to represent as angle I. Angle I represents incident angle. And you have to take 2 pins. And fix on this line like this. You have to take 2 pins and fix on this line. So after fixing these pins, you place a mirror strip. I don't have mirror strip. I have like this. So if you place a mirror strip like this, and if you find, you can get the image of these 2 pins in this mirror. You place the mirror strip here on this line AB, and you see you can get these pins. You can take it as M and N, or otherwise you can take it as P or Q. Any letters you can, with any letters we can represent. So in our textbook it is given as P and Q. So if you find the image of these P and Q pins through this mirror, you can get somewhere here. You can get the image of these 2 pins somewhere here you will get. Okay. Like this you will get the line in the mirror. So here on this here you will get the image of P and Q. And these points, when you extend along this line, you take two more pins and fix here on the front side of the mirror. Once again, you will get the image of this PQ in the mirror. So by seeing this image of the mirror by this pins, these images will take it as P dash and Q dash. P dash and Q dash. So by seeing this image, you put two more pins as such that these two pins and here the image of these two pins should lie on the same line. So when you observe from here, you should get it, all these four pins should lie on a single line. All these two pins and these two pins should lie on the same line. So remove these pins and mark it, and by using the scale, just you draw the line. Remove the mirror and remove the pins, then you draw the line by using the scale. Then here you will get one more angle. Here I said to fix the pins, that pins we have to take R and S. We will represent that pins are R and S. Then if you find the angle between normal and this is known as reflected ray and this is known as incident ray. Then it is represented with the angle R, this it is represented with the angle I. By using the protractor, if you find the angle here we took how much? Angle of I? Angle of I is equals to 30 degrees. Obviously, you will get angle of R also 30 degrees. Maybe 1 or 2 degrees you might have get a change. So, angle R also will get 30 degrees. Or otherwise, we'll get the approximate value. Either 29 or 31 like that. So, like this, you have to find out with the different angles. Here angle of I is 30 degrees. Now next time you take 40 degrees, 60 degrees. Like that you take with the different values 4 or 5. Then all the values you have to write in a tabular form. So what is our observation? So write all the first angle is 30 degrees. Angle of reflection is also 30. Next you take 40 degrees. You will get definitely, obviously the angle of R is also 40 degrees. Next to take 60, you will get 60. And 75 you take, you will get 75. So here angle of I is equals to angle of R? Yes. In each case, we are getting angle of I is equals to angle of R. So this is about the procedure and observation. Now, here precautions, already one precaution I explained. What is one more precaution? While you are fixing the pins, we have to fix that pins carefully. We have to fix the pins carefully and we should not disturb. Next, what is the final observation? What is observation? For any angle of incident, the reflection is also same. From this, we can prove the laws of reflection. So here we proved angle of I is equals to angle of R for only first law. And what is the another law? Incident ray, normal and reflected ray. All these three lie on the same plane and will meet at the same point. Here you see, this is the incident ray and this is the normal and this is the reflected ray. All these three are touching at the same point on the same plane. Here in this picture, plane means actually that is mirror. Here this is on a whiteboard or on the same plane at the same point. So two laws are proved. Thank you.